This harvest, grain growers across the southern region will be counting the cost of the devastating frost that caused grain, leaf and stem damage to many cereal crops. However, the new year will bring good news for growers in frost-prone areas. For the first time, national variety trial data will include frost susceptibility ratings for 120 cereal varieties. It's taken 3 years to produce these rankings through the combined efforts of the University of Adelaide and DAFWA in the Australian National Frost Program, now part of GRDC's National Frost Initiative. The ambitious task of rating frost susceptibility required groundbreaking research, and that meant overcoming a number of challenges before field trials could begin.
Frost is uniquely challenging in terms of its sporadic nature. You can't really predict, when it's going to occur. And also it varies, of course, in its severity. So choosing a location was obviously a challenge where we can get reliable occurrence of frost events of a severity that's relevant in terms of commercial production, but also a growing environment that reflects broadacre cereal production. So in the lead up to this program, we were involved in field testing frost reactions in barley in particular at a range of locations across the southern region, and finally settled on the Loxton location as somewhere reliable and able to give meaningful sort of frost events.
Loxton in South Australia's Mallee region is one of 3 major centres undertaking research for the Frost Susceptibility Ratings project. The other centres are in Merredin in Western Australia and Narrabri in northern New South Wales. Having found the right sites, there were other hurdles to clear in establishing the necessary phenotyping protocols.
There are a lot of things that can confound or interact with the effects that we see in terms of frost damage that occurs to a plant. And certainly what we need to do is try and minimise all those confounding effects through experimental design and through the analysis approaches. Now, of course, trying to look at a range of different varieties, they obviously differ in their developmental pattern, their time to flowering and so on. But in order to make sure we're comparing varieties at identical stages of development, and so we're not confounded by differences in their growth rates or development rates, we use, in this case at this site, we have 10 times of seeding of both wheat and barley to ensure that whenever a frost event does occur, we have the majority of those varieties at the same developmental stage to allow us to directly compare their performance.
The developmental stage the program is focused on is flowering, because it's the plant's reproductive organs that are most susceptible to frost. And while cereal growers this season saw vegetative damage to their crops, frost-induced sterility is still the most common form of frost damage.
So what we typically see is florid abortion, whether that's through effects on the pollen principally, but also the other floral reproductive structures are far more sensitive to frost damage than vegetative structures. So typically what we see is intermittent floral sterility, and that can range from just a couple of % of missing kernels through to 100% sterility in a head.
The question, how does sterility affect yield loss, is outside this project's focus. It is being investigated in GRDC's wider National Frost Initiative, which incorporates this and many other frost projects. That project will look at a cereal's ability to compensate for frost damage, either by surviving grains filling more fully or by the production of secondary tillers. Another challenge for the program's team was the size of the trial and skilling up the necessary workforce.
Well, the scale of this project is fairly significant. So the site we're at the moment, we have replicated trials with 72 wheat varieties and some 48 barley varieties with 10 times the seeding. And the actual phenotyping protocol involves staging the development of individual tillers following a frost event, tagging those tillers that are at the appropriate target stage of development, and ultimately later in the season harvesting those tillers, counting the number of sterile and fertile florets. So last year the team got through more than 1 million individual florets that were scored for sterility for the purposes of developing these wheat and barley variety ratings.
What varieties to trial also had to be considered, and to be meaningful to growers, the bulk of lines are commercial releases. However, there are some yet to be released new varieties and some important old standbys.
So Wild Catchem is one of our long-term checks, and despite that being a major variety historically in the western and southern regions, it is actually quite susceptible to frost damage at flowering and early grain fill. So it's our long-term susceptible variety. And Yitpi, which is also a fairly old variety now, but it consistently shows much less frost damage than Wild Catchem. So they're two of our benchmark wheat varieties that we've included in the trials over a long period now. Certainly, if we look at the differences between just say Wild Catchem and Yitpi, the difference in frost sensitivity is economically significant. And so being able to benchmark the current and new varieties against those will provide growers the opportunity to avoid any varieties that show high levels of sensitivity of frost. And so that certainly be a key outcome. Following the consolidation of 3 years worth of field data, we'll be able to make those recommendations in the early part of next year. And it has those direct outputs to growers, but also provides some valuable information that'll be incorporated into breeding, because you can imagine major varieties like Wild Catchem have been used extensively in wheat breeding, and being able to avoid the level of frost sensitivity that variety shows, that'll be an important objective for wheat breeding.
It took several years to establish the necessary protocols for the Australian National Frost Program. Another 3 years on, and frost susceptibility ratings for 72 wheat and 48 barley varieties will be released in 2015 as part of the National Variety Trial data. And under its National Frost Initiative, GRDC will invest $5 million annually over the next 5 years so that a combination of genetic and management solutions can be delivered to grain growers.
Obviously, with the establishment of this program, and now we have the scale and confidence in the field-based phenotyping to really reliably measure frost damage, it does give us the opportunity to look more broadly internationally to wild and exotic sources of germplasm that may potentially offer us improvements above what the best wheat and barley varieties currently offer.
Additional information about other projects in GRDC's National Frost Initiative can be found online in Groundcover's Frost Supplement. And keep an eye on MVT Online for those frost susceptibility ratings.